Want to put on the next slide, please? Great. Well, good afternoon, everyone. Welcome to the Penn Alumni Forum Speakers Spotlight. I'm Howard Newkrug. I'm the founding director of the Water Center at Penn. I am thrilled, really thrilled to welcome to our show today the Water Commissioner of the City of Chicago, Commissioner Andrea Cheng. Chicago's Department of Water Management, overseen by Commissioner Cheng, delivers nearly 1 billion gallons of drinking water a day to 5.5 million people in the greater Chicago area. Within her portfolio is the operation of the world's largest water treatment plant, the Jardine plant, which is located on Lake Michigan. Moderating our discussion today will be with Commissioner Cheng is Mr. Neil Jain, the president of the Penn Club of Chicago. He is a Wharton MBA in strategic management and marketing and holds several other prestigious degrees from the University of Pennsylvania in finance, strategic management, and system science. I'd also like to give a quick shout out to our partners who made this event possible: the Penn Alumni Water Forum, Penn Club H2O, Penn Club of Chicago, and of course, the Chicago Department of Water Management. Thank you all. Before we begin, next slide, please. Just like to tell you a little bit about the Water Center at Penn. We are a global water research and policy hub based on the core values of community, equity, science, resilience, and justice. Our work is founded on the principle that clean, accessible, affordable water is a human right, and we support communities in meeting their critical water challenges by identifying resilient and sustainable solutions based on equitable principles that reflect community voices. And we also support the education, the development of future water leaders in these communities and within the larger water sector, so that water decision makers reflect the communities they serve and have all the tools that they need in order to run a successful utility. Next slide. And just a little diagram here to show what our core themes are. I think you probably heard it just now because I keep mentioning equity, resilience, and leadership. Those are really what we're all about here at the Water Center at Penn. And we do this through applied research and programming with many different projects that are ongoing and have been completed. And and we also do a lot of networking, both with utilities and communities in Philadelphia, in Pennsylvania, throughout the US and throughout the world. We engage students and others to participate with us in this research and in our development of our center. And we're also like to think of ourselves as mentors, where we're mentoring these next generation of water leaders. And now I'd just like to turn over the podium to our moderator, Neil Jain.
Thank you, Howard. Again, my name is Neil Jain. I'm so excited to be moderating this discussion. Wanted to start off with a couple of logistics and summarize the agenda today. We're going to have a 20-minute presentation by Commissioner Cheng, followed by Q&A. Anyone on the Zoom should see at the bottom of their screen the option to choose Q&A. Please submit any questions you have during the presentation, and we'll try to get to as many of them as we can after Dr. Cheng concludes. This event is being recorded and will be distributed by the Water Center via YouTube. So to kick things off, it's my pleasure to introduce Dr. Andrea Cheng, who is the Commissioner for the City of Chicago Department of Water Management, where she spends her days working on her passions: drinking water quality, lead corrosion, public health, and water meters. All exciting stuff. As a licensed professional engineer and a Class A public water supply operator in the state of Illinois, she's been with the department since 2004, almost 20 years. Andrea is responsible for ensuring drinking water safety throughout the Chicago system. She's published over 40 times in peer-reviewed journals and has a BS in civil environmental engineering from the University of Illinois at Urbana-Champaign, and her MS and PhD in Civil Environmental Engineering from the University of Texas in Austin. Please welcome Andrea Cheng.
Thank you so much, Neil. You know, as you read that out loud, I realize that perhaps my passions make me sound a little bit crazy, but that's okay. In a good way. In a good way. That's very me. I am a huge water nerd. So I just, before I put the slides up here, I wanted to say it's such an honor to be here today. And, you know, thank you, Howard, and the Water Center at UPenn for having me. Thank you, Neil, for moderating this. This is really exciting. So let me pop up my slides. This is sort of my favorite first slide. It is a picture from the cover of a popular mechanics magazine from the 1940s. And I say that because in today's modern world, I can't even imagine a picture like this being on the cover of any magazine in 2023. But, you know, people were still very curious about how water got to their homes in the 1940s in Chicagoland and Illinois. This is a picture of the crib being built, the crib being our intake, our water intake for our, at the time, water pumping stations, because this is pre any kind of water filtration. And it was quite a feat because it's a few miles out into the lake. And the very first crib was built in 1867, only 2 years after the Civil War. So, you know, people were still fascinated by the 1940s of how they could possibly have built this huge tunnel a few miles out into the lake that was about 125 feet into the lake bed between this crib up here and the lake bed down here. So it always helps me keep grounded in terms of expectations and how we got here when it comes to thinking about public water supply. So that's my intro to this, which is really my kids say it's not a meme. Technically, it's not a meme. I think of it as a meme. But when I think about being a public engineer, being in the public sector, and the important work that we do here, things like that crib that we just saw that lasts for decades. You know, I always think about what do other people perceive of the public sector, and you know, the upper left, what my friends think I do, for sure, as I, you know, push up the glasses. What my kids think I do, I should preface this by saying I have 5 kids, and so they have a wide range of thinking what I do, but they know it's something with a hard hat and water, and it's important. What society thinks we do is fairly negative perception, often incorrectly, but what I think I do, right? I think I'm this, you know, super cool person tapping a water main in that picture. What I really do is the bottom right? It's a lot of, in my current role, it's a lot of stress and management and trying to find a good balance with everything. And, you know, when people think about public sector work, you know, of course, there's the usual but true benefits, right? You have your better work-life balance. You know, people stay late, but it's not an 80-hour work week, and you have a consistent level of work. You're not out there having to do sales. And there's good insurance, and the promotions, they take time, but they're more predictable. There's a fairly regular cadence of promotions. Sure, all that's true. But the really cool thing about being in public works, and sort of the things that keep me going, even on rough days, is the benefit to the public good. Getting to really see the impact of my work. Like, I'm going to talk a little bit here about lead service line replacement in our programs, and being able to do our first lead service line replacement and walk up to the customer and shake their hand and see how happy and impactful it was to their life is unbelievable. And the infrastructure that we're building will outlive us and our children and our grandchildren, right? The programs we put in place, the initiatives, the physical infrastructure are all incredibly impactful to the bigger society. Our communities really do deserve the best, the brightest, the most dedicated engineers. I truly believe that, as a PhD, I often get asked, why did you end up going into public utility work? And I think it is because we should be taking our most dedicated engineers and throwing them at the challenge of public utility work. It can have benefits to the entirety of the public. Why not, right? And in huge service areas means there's a huge impact, right? So a good example of this, is our service area. We have Chicago here in sort of the light green, and then this is all of the suburbs that Chicago currently serves in all these different colors. I mean, they're just different colors from when we added them into the system. So it's definitely grown over time. For clarification, when that crib was put in place in 1867, our service area was just about here, just downtown Chicago, right in the middle, but it has grown significantly. So that's, anything we do, any policies we put in place, any treatment changes we make impact all of these people. That's a responsibility we don't take lightly. So here at the Chicago Department of Water Management, we handle that drinking water treatment itself. We pull it out of the lake, we treat that drinking water, we distribute it to our 12 pumping stations, but we get it through the entire water distribution system to people's homes, right? But then we also take that wastewater from people's homes, we combine it with stormwater, and we send it over to our colleagues at the Metropolitan Water Reclamation District. They handle the wastewater treatment. So I feel like we have 3/4 of the pie of water and wastewater world. We have the, taking in the fresh water, treating the fresh water, taking in the wastewater, just not treating the wastewater. So we work as a sister agency with them. But we do serve the city of Chicago and 120 suburbs, which is almost half the state of Illinois. It's 5.3 million people. So the impact of everything we do is not lost on us as we make those decisions of how we move forward. We have a fairly large system, as I mentioned. We have 2 cribs, so 2 water intakes that are a couple miles out in the lake, 2 that are functional. We actually have 5 overall, because over the years we have installed new ones that have been abandoned since, but people actually used to live on those 24/7, if you can believe it, for 2 weeks at a time. And not much to do but play cards and fish out there and try to maintain the crib. So now these days we have a tugboat, an icebreaker that goes out and maintains those cribs to make sure that we never have a ice blockage or anything else that keeps the water from flowing into the treatment plants. And this picture here on the right is a picture of Jardine. Jardine is the world's largest conventional treatment plant, the world's, which is pretty unbelievable. Nestled right here in downtown Chicago. The capacity is 1.4 billion gallons a day, billion with a B, which is just enormous when you think of that in terms of a gallon of milk, and 1.4 billion of those a day. It was put in place in 1964. It took about 12 years to build. But our Sawyer water purification plant on the south side down by Rainbow Beach was actually put in place in 1947. And it has about half the capacity. It is right now about the world's 8th largest. And, if you do the math here, and I tell you that before 1947, we never had any water purification plants at all. We just pumped water to pumping stations without any kind of treatment and pumped to people's homes. You do the math, Jardine serves the north side, Sawyer serves the south side. So for the north side, they didn't have treated filtered drinking water for almost 20 years after the south side did, which is pretty crazy. And there's old newspaper articles where they used to make fun of the north side for not having filtered drinking water, and they would, there's articles of they'd open up the faucet on a stormy day and there'd be like some sediment from the lake in there, or maybe some tiny fish. So I can't even imagine having that much disparity for almost 20 years. But that's what it was. And really, even before 1947, just water pumping stations and lake water through, by the way, wooden water mains. If you ever happen to come to Chicago and go on a tour of our Jardine plant, you'll see them on display here. And for the record, they are not currently used. We do not have wooden water mains in use anymore. once it's treated and it's gone through either the Jardine plant or the Sawyer plant, it goes to one of 12 pumping stations throughout the city, because when we take that water from the crib and bring it into the plant, we pump it up 25 feet, and the rest of the way it flows by gravity all the way into the pumping station several miles away. So it's really a pretty incredible engineering design. And when it gets to the pumping stations, we pump up the pressure to make sure that when it gets to people's houses, they can, take a shower on the second floor. We want to make sure that we're hitting the right PSI out in the distribution system. And some of those pumping stations are actually still run on steam pumps because they were built well before the water purification plants. Some of our oldest are from the late 1800s. Once it's gone through those pumping stations, it goes through about 4,300 miles of water main. And it's an easy number to say, 4,300 miles of water main, 4,600 miles of sewer main. But when you think about it, it's pretty much equates to a water main or a sewer main under every city street in this entirety of the city of Chicago. So you can't dig here without hitting something from the water or sewer infrastructure in Chicago. And so that's a tremendous maintenance need. About half of our 2,000 staff that we have in this department are out in the field maintaining those water and sewer mains, either emergency repairs or planned maintenance. We also have appurtenances like catch and valve basins, fire hydrants that we're all also responsible for maintaining in the distribution system. So very large impact in terms of public works. There we go. So really, public sector water engineers got us where we are today. When I think about the engineer that designed that water purification plant at Jardine, and he also designed the one at Sawyer, I am eternally grateful for some of the clever engineering designs that he put in place and that we get to enjoy today. But originally, before those purification plants were built, and you rewind a little, I think most people know the story of the reversal of Chicago's river, but in case you don't, originally there weren't sewers in Chicago, and people's waste just eventually made it to the Chicago River. And we had all that water going from the Chicago River into Lake Michigan. And that polluted water was making it to the waterworks, because at that point, the intake before we built our crib a few miles out was just about 150 miles into the lake. So think of like a straw into a beach. That's really what it was. It was still a sandy beach, 150 feet in. And that was the source of drinking water for folks. So typhoid, cholera were rampant. And that was the source of our drinking water. And basically our wastewater became our drinking water. And then along comes Ellis Sylvester Chesbrough, who's probably a name that most people don't know. And I'm always trying to get people to know because, his grand design for improving public health in Chicago is really what got us to the point of even being able to talk about, pumping stations and water purification plants. He looked at the problem that we were having here with the contaminated water making people sick. And in 1858, he came up with the idea of raising downtown 4 to 14 feet up in order to construct sewers underneath. Just think about that for a moment. Every building in downtown Chicago, there was these screws, and there's photos of it, these giant screws that were slowly, turned to crank up houses 4 to 14 feet so that they could install sewers. So imagine that feat. Imagine the first time that he must have proposed that idea. What people must have thought. It was probably insane, but it worked. And sewers were indeed constructed, because before that, literally there was a lot of waste in the streets. And there's pictures of these like wooden boards that people would walk over that were rotting away, basically because they're sitting over wet material. And occasionally somebody's foot would go through, and you'd have a very bad day that day if you happen to step on a rotting wooden board as you tried to walk somewhere downtown. So that, is the first step, right? Get control of the source of the contamination, get it into a point source. After that, he said, hey, you know what? Maybe we shouldn't be taking drinking water from just 150 feet away from shore. Maybe, how about a little farther? So thus the idea for the first tunnel out to what we call the cribs, extending out about 2 miles into the shore. So again, 1867, and you think about that, and you think about the technology that was available at the time, 2 years after the end of the Civil War. And again, probably another idea that people said, oh my gosh, how would you possibly do this? But here we are. The first crib was indeed constructed and put out into the lake to find a fresher source of drinking water, so that at least you could get farther away from the pollution source. And then in the late 1860s, he came up with the idea to reverse the Chicago River. So literally to change the course of a natural flowing river to take that contaminated water away from Lake Michigan instead of into Lake Michigan. It wasn't completed until after his death, but literally, the idea was to build the channels to reverse the flow. Another incredible feat. And if you get a sense of what it was like building a crib in 1867, this is sort of the drawing of what it looked like at the time. They constructed a crib exterior. They floated it out 2 miles, sunk it with brick, and then from both the shore and the crib met in the middle. But they started building the tunnel from both sides, and they were only about 7 inches off when they met in the middle of a 5-foot diameter tunnel, which is really impressive because remember, this is before AutoCAD, and this is 30 feet below the lake bottom. So incredibly dangerous work, but really, really important and impactful. And this is just a image of them floating the exterior of that crib out 2 miles before they sunk it with bricks. And this is what they had to do to reverse the flow of that river. They had to build all these channels in red, were dug in order to get the flow of the naturally occurring rivers in blue to be reversed. So instead of that going into Lake Michigan, it flowed from Lake Michigan down to, unfortunately, Missouri. So they didn't like that very much, as it turns out. And this is actually a photo of them digging those channels. It wasn't completed until about 1900. And as you think about these big public sector projects, those projects impacted everyone in the Chicago area, right? That was something that everyone got to reap the benefits. But continuing to make sure that as a department, as an industry, that we focus on equity, that is the key to successful public sector projects. And so that is a really important focus for us here at the department. And we've been looking at all of our programs through the lens of equity and making sure that we're doing things equitably now, but that as we come up with new initiatives like our lead service line removal programs, that we are looking at them through an equity lens. So thus, we came up with our equity lead service line replacement program. So how did we get there? I preface it with that we have about 400,000 lead service lines in Chicago, which is the most of any city so far. We have a lot of people that haven't finished their inventories yet, but we're pretty sure, unfortunately, that we have the most. That's because we literally enforced a mandatory installation of lead until 1986, which is pretty insane, but that's what happened. Unfortunately, it's partially owned by the city on the public side. So that's from the water main here in the street, this circle, all the way to B, which is our Buffalo box, our B box. It's our outdoor shutoff valve, basically. This side is publicly owned. And then this side is privately owned between the B box, all the way into the house. So like anything that's owned by 2 people, trying to replace it is not fun. We need things like the homeowner's permission to be able to work on the private side of a lead service line. So we had to come up with a lot of strategies to be able to make sure we had a successful program that was equitable while still replacing both sides of that lead service line. We are currently below the lead and copper action limits. We have a good corrosion control program. That's a whole nother talk. But of course, it's time to do lead service line replacement. We still have an issue with lead paint in Chicago, unfortunately. That is a source of lead poisoning here, but any contribution from lead service lines is obviously not a good thing. So while we continue to optimize our corrosion control and do all the other things that we need to do around lead paint, we commenced the first ever lead service line replacement program in 2021. So to be clear, before that, we had never had a lead service line replacement program. Some cities have done it where maybe they replace the public side over time. No, we have done none of that. Because always perceived as something that would be impossible to do because of the sheer number that we had and the cost. So the full replacements here, about $15,000 to $26,000 each. It's much more expensive here than it is in most other places. So that ends up being about $6 to $10 billion for removal of all these lead service lines over time. Of course, we're continuing to ratchet down on those costs and look at different construction techniques, but regardless, in the end, it will always be more expensive here. We've also distributed about 100,000 free lead testing kits. So for a long time, we've offered free lead testing, but we really ramped up in 2016 and kind of converted from going to somebody's house, knocking on the door and taking a sample to we're mailing these out because there's such demand and we want to make sure it's really accessible to everyone, so we can get a better handle on confirming where these lead service line replacement or these lead service lines are. We think we know where they are, but the lead testing kits are helpful in that. And also, most people don't have high lead in Chicago, but if they do, we want to make sure that we're targeting those folks first as we look at lead service line replacement. So because of that, we actually have the largest lead database in the US. We have our kits have multiple bottles. And we do a lot of sequential testing, meaning we do not just one sample at a house, but a whole series of them. So we can get kind of a profile of lead levels across the service line. So we've been able to really use that data to help inform our policies and our programs to benefit everyone, every neighborhood. We've also been distributing water filters for anyone who might have had any kind of disturbance, whether or not they have a high lead, just to be on the safe side. So we've actually distributed about 61,000 of those so far. And so like I said, prioritizing equity, making sure that this public sector project that we have that's going to have really big, impactful, big impacts to the entirety of the city of Chicago is done right. So we wanted to make sure that we prioritize equity from the start, took our time, make sure that we learned from what other cities did and didn't do that worked, lessons learned from everyone else. And also, tailor things to the reality here in Chicago of how our customers react and knowing what works best in terms of implementing programs here in Chicago. So the equity program for lead service line replacement is a very unique one. We were actually able to use community development block grant funding, CDBG, which is usually used for other like home repair things for low income homeowners. So like a roofing program, rebuilding porches in low income neighborhoods, things like that. So it was really a little unique to use it for lead service line replacement, but we did. And we were able to provide free full lead service line replacement for low income homeowners, meaning the private and the public side. It had to be a homeowner because of the grant requirements. It's a federally sponsored HUD grant. So each of these funding sources that we have comes with stipulations. And that's one of the things that we really had to work around. And I think a lot of utilities are working around is how do you best use the incoming funding sources while recognizing that each one of them comes with different requirements, different reporting requirements, and keep the accounting straight. So you're pulling from the right bucket with the right programs. So with that equity program, we're able to fund about $600 a year. And, we really focused a lot of the outreach efforts on our low income neighborhoods on our south and west sides, but in particular for those that we already had in that big database I referenced as having high lead. Because anywhere that we had high lead, we've actually been sending out our engineers, as well as a plumber and an electrician to each of those homes and trying to provide customized recommendations. For example, sometimes they had dissimilar metals sitting next to each other in a home. And that's an area where we could recommend, hey, if you're able to be able to have a slight change in plumbing here, you can reduce the galvanized corrosion that's happening. And, that's contributing on top of everything else. So we're able to, you have a vacant second floor in your home. You know what? Just going up there and flushing that water once a week is going to reduce your lead levels because you have huge corrosion issues going on there, and so because of that, we had that outreach established. We had a familiar face and name from our department that person and that homeowner had seen. And so we were able to leverage that as we performed outreach for equity. We were able to we had that person call up and say, hey, it's me, it's Andrea. Remember, I came out and provided those customized recommendations for reducing lead levels. We have a new program. Great news. Are you interested? Let me help you fill out the paperwork. So it's a lot of hand-holding because there is a lot of paperwork associated with that program being a federally funded program, but very impactful. We're reaching those neighborhoods. I didn't want the one low-income house in a wealthy neighborhood. I wanted to reach the low-income neighborhoods themselves. So that was a really impactful way to try and do that. We also started last year our daycare lead service line replacement program. That's also free full lead service line replacement. We prioritized daycares that were in low-income neighborhoods with our first round of funding that we got. That was also some SRF, State Rolling Loan Fund funds from the EPA that had some principal forgiveness. So we were able to use, with that principal forgiveness, we were able to do work on the private side. So there's a lot of stipulations around our operational funds that we can use the public sides versus things like grants that we can use for the private side of a lead service line replacement. And then at the end of 2022, we began our breaks and leaks pilot, and now it's full scale in 2023, meaning every time we have a break or a leak on a lead service line, it becomes a lead service line replacement. And that sounds simple, but it's a big deal. We had a state law passed in Illinois that basically banned partial lead service line replacements. And, specifically, you can't do a repair on something like a lead service line and walk away. It has to become a full lead service line replacement. You can't go along a water main or a sewer main replacement project and reconnect lead service lines back up to the new main. It has become a lead service line replacement. So to all the communities in Illinois were getting up to speed with that. But for us, that means 4,000 to 5,000 lead service lines replacements alone from breaks and leaks, because that's about how many breaks and leaks we have on lead service line replacements a year. So that's a tremendous number. And that's, a program unto itself. Really, that's going to be the main driver of our overall program for the next few years. We certainly, a lot of other cities are focusing in on these, what we're calling programs 4 and 5, lead service line replacement alongside water and sewer main, because you can go along the block, but it's probably the most difficult from a construction and logistics perspective, is the most difficult way to do it. You have to get into each of those people's homes along the block, and you don't want to have any one person hold up an entire project. So outreach is super, super key. And what we're finding is with leaks and breaks, when you already have a break and people are repairing it on your front lawn, there's already a hole in your front lawn, it's a lot easier for you to say, sure, go ahead and do my private side. No problem. Than it is here, where they don't see a hole on their lawn. When you're talking to them, trying to get them to join the program, they see their beautiful front lawn and they don't want you to touch their hydrangeas. So it is a lot more convincing that has to occur. But it is a worthwhile endeavor nonetheless. So, and people usually don't think about lead service line replacement when they think about sewer mains. But if you know how a sewer main is replaced, often you have to cut through lead service line replacements on what they call the long side of a water main in order to access the sewer that's below. The sewer is deeper than the water main. And so what they would normally do is cut those, bend that lead service line back, perform the work on the sewer main, and then bend the lead service line back into place. So yeah, it means that now we do lead service line replacement associated with sewer main projects. Not intuitive, but necessary. We also have our homeowner initiated program where we waive permit fees for any homeowner who just wants to do it on their own. Not going to be a ton of people that have a spare $20,000 sitting around, but we have had about 40 people do it this year. If they happen to be doing other work in their home and they have a contractor, great. One less one that we have to coordinate. So something that was kind of an easy, no-brainer. And this gives you a sense of our volume overall. A lot of the newspapers didn't quite get it right when they talked about our volume in Chicago of lead service line replacement. They'd say, oh, they'd focus only on the equity program. You're only going to get 600 done a year. You'll never get 400,000 done. Well, of course, that's not our only program. So that was just what we wanted to start with. This is what our volume sort of looks like over time, with the yellow being that leaks and breaks. So you can kind of see that's really the big part of your lead service line program early out. The daycares is a smaller number. We really don't have a ton of daycares with lead service lines. It's usually our smaller one, our mom and pop type daycares that have lead service lines. And block replacements are in blue, meaning water and sewer main, or just lead service line replacement without any water and sewer main, as well as our equity in orange. And this is sort of based on private side participation, what we would consider a full lead service line replacement. So we're thinking it's going to end up being a max of 9,000 full lead service line replacements, because the EPA does not count it if you only do the public side. If in the end the homeowner says no thank you for a free private side replacement, there's a waiver you have to fill out and everything, but we won't count that. So this is how many we think will get completed with where the homeowner does say yes to the private side. And of course, this is, the funding challenges are significant to equitably replace lead service lines. Making sure that that's done in a way that maximizes the participation on the private side is absolutely key. And we have to do that while maintaining affordable water rates. And that also means while complying with previously issued water bond covenants, meaning, we bond out a lot of our capital work, and that each of those bonds has a covenant, a promise, an agreement that we made with those bondholders. And it defines what the Chicago water system is. So there's not, without going back and renegotiating all those previous covenants for 20 years, we can't redefine the water system very easily. And that means that our water fund can only fund the public side of a lead service line replacement, which in the end still goes back, even if it could, the amount of water rates that you'd have to raise to cover the public side, it's hardly a solution anyway. But then of course we look at the IIJA, right? Our Federal Infrastructure Investment and Jobs Act. And we all just have that money, right? Well, not quite. It gets a lot of press, and I unfortunately am in the situation where a lot of residents think I'm sitting here with a pile of cash that just came from the federal money and we're like not spending it. But of course, that's not the case. That money is allocated to each state for distribution, and that allocation has nothing to do with the number of lead service lines in each state. It's based on the needs assessment that was done by the EPA a number of years ago. So it's really based on just other water infrastructure needs overall. It's not based on the most recent needs assessment, which included lead service line replacement. So hopefully at some point that will change, but currently it doesn't. So that means Illinois only got $107 million per year for 5 years. $107 million. I have an $8 billion problem. And that's 107 for the entire state of Illinois per year. So, and that's not all with principal forgiveness, right? That's not a grant, that's a loan. State revolving loan funds, as you push federal money through the states, are allocated as loans. So that means I have to pay interest on it using my water fund. So that becomes a challenge, right? What I can use for the private side is state revolving loan funds with principal forgiveness. So only a portion, only about half of that 107 million is allocated to be given out as principal forgiveness. So then once it gets to Illinois, of course, then they have to decide how much does each city get within Illinois. And that's not necessarily decided based on the number of lead service lines either. So that's still being figured out within the state level here. And, creativity is key. We went, we participated with the Federal Reserve Bank convening in fall of 22, which was like a really great example of a lot of different folks coming together to try and figure out how we can creatively fund some of this. And, a good example being that those CDBG grants, that wasn't something that people had really thought about. And we also were able to work with the state to create a variance to allow trenchless construction, because before that we were actually not allowed to use trenchless construction without moving our private drains, our sewer section far enough away from our lead service line. So we would have had to basically do 2 capital projects at the same time. So in order to be able to do the most efficient, cheapest construction techniques, we had to make some changes as well. And, really making sure we continue to think about equity at Chicago Water is key, because it also helps attract the next generation of leaders in public service. I can't do all this work. I can't do $8 billion worth of lead service line replacement work without hiring. We need a lot of people. We hired 400 people last year and it wasn't enough. But it's hard to attract folks to the water industry. It's not Google. It's not, some of the well-known places that an engineer can go work. And so trying to make sure that the next generation sees the benefits of working at a public water supply such as my own is really important. The next generation often wants very fulfilling work that focuses on social good, on equitable outcomes. And this is a great place to be able to enact those kind of outcomes. And we really don't have a lot of diversity in the water industry at all. And we have a great brain drain, as they call it here, a lot of retirements in the pipeline. And so that's hitting us at the same time as well. So we have an opportunity here to bring diversity, to bring fresh blood into the water industry, and to do that at the same time as we're focusing on the social good and the equitable outcomes. So hopefully, I can continue to work on getting more people to think about public sector water utilities as an option, as a career, for a fulfilling career. So our focus is building on that awareness for Chicago Water, for the entire water industry, for careers that can be focused on that social good. And, we have some water operator training program that we're working on to try and build folks in from the high school level. But also, if you want a little chuckle, look up drinkchicago.com. Chicago is supposed to sound like the Native American word for Chicago. It's very similar sounding. So it also sort of sounds like Chicago agua, in Spanish. So it's sort of our awareness campaign as we try to get people aware of even where does our drinking water come from, and how is it treated, and try and get people more engaged as a first step towards getting people to want to come work here. So, with that, I'll take some questions. I think Neil, you might have some questions as well.
Yeah, that's great. Thank you very much for going through that. While I orient myself, I have a very basic question. Why was lead used in the first place?
Oh, great question.
I don't even know. Yeah,
so it goes back to Roman times. It's a very malleable, if you think about the properties of lead, it's very malleable. And it actually doesn't corrode as fast as other things like copper. And it was fairly plentiful. So you could use it in a lot of situations where you could bend things around very easily. And you even see it today, as we replace lead with copper lines, we have some difficulty because the copper is harder to bend. And there's some kind of circuitous routes that some of these service lines took that are hard to replicate with copper. But they only make copper up to 2 inches. So that's the other thing to keep in mind. I have to do a lot of education here. If you're listening in a big high rise, you probably have a 4-inch service, a 6-inch service coming in, you use more water. They didn't make lead up to that. So that's probably cast iron or copper. And, when I got lead test kits from some of the very fancy new high rises in downtown here, I was like, okay, well, you can run this test, but maybe let's do some education about why you're wasting your time, so.
Got it. And I presume it's cheap, or is pretty cheap relative to
yes, that as well. Mm-hmm.
Got you. I'm recalling the chart you had talking about 50 years worth of work on the roadmap, but it looked like a lot of those equity programs were we're supposed to conclude the work by 2028, even within the hundreds or thousands of constituencies and recipients of that service, how do you manage prioritizing that? Because I would imagine everybody's raising their hand, I want to be first.
You'd be surprised. It's very much by neighborhood. And that's the huge equity part of it, because in some of our neighborhoods where there's a lot of distrust of city government, sometimes well-earned, unfortunately, the assumption is that there's going to be some price to pay for getting a free lead service line replacement, that either there's going to be some down the way cost that we're hiding, or it's gonna have some negative impact, right? And there really isn't, but it's, you know, me knocking on doors saying, hi, I'm from city government, this is a great program, is not what they want to hear, right? So that's how we get creative with trying to use community-based organizations, trying to, you know, work with our aldermanic offices, trying to find, you know, honestly, neighbor to neighbor contact is really important there. People are going to trust what their neighbors say a lot more than me. So in some of our neighborhoods that tend to correlate with our low income neighborhoods, we do have the biggest challenge in terms of getting people to say yes. In our wealthier neighborhoods, yeah, they're knocking on my door saying, when's my turn? And we see the same thing with trees as we do this lead service line replacement. Unfortunately, it's quite a few trees that are built right on top of the lead line and the private drain right next to it, the private sewer lateral. And sometimes we have to take that tree down. Sometimes there's no avoiding it, and we put a new tree in, but people get pretty upset in our wealthier neighborhoods because they're losing their tree, understandably. And we try and utilize trenchless construction to get, you know, to avoid it as much as possible. But in some of our low income neighborhoods, they want the tree down because the tree represents a burden. The tree roots break into their private sewer lateral. That means they have to pay for repair. The leaves clog your gutter. That can lead to, you know, problems in your home. It's seen as a burden instead of a benefit. And so there we're trying to save the tree, and they're like, no, take it down. And I'm like, no, I'm trying to save the tree. So it's similar with lead service line replacement. It's like trying to convince them that really this is a good thing. And I'm really, based on what I've seen with some of our other programs, where we had to sort of get buy-in, it will, once we get a core of number of lead service line replacements done, particularly through our equity program, where we're making that particular push in low-income neighborhoods, we will start to see people talking to other people. We will start to see a greater acceptance, and then we will be able to accelerate a little bit more. But it just takes a lot of heavy effort on the front end to make sure that we are really focusing on those neighborhoods.
Right. Success breeds more success.
Exactly. When the more that people can say, oh yeah, you had that done and nothing bad's happened, and it was, you know, it was a good story, everything's good. Okay, all right, you know, that's great. And that means doing it in multiple languages as well. You know, thankfully we have a really, you know, people on our staff that speak multitude of languages that are, you know, seen reflected here in Chicago. So we've done things like do news interviews in like in Spanish with a homeowner that speaks Spanish, and you know, be able to run those so people can see, you know, and be able to hear this in their own language, because it's a fairly complicated thing. This is a construction project. This is not something where you push a button and your lead service lines are placed. And I think that's a pretty common misperception. Like, we need to get into people's basement. We're putting a hole in their wall or in the floor of their basement. Even with trenchless technologies, you have to pull that out. People do not realize that. And so, you want to be able to communicate that in their native language to the extent possible. We don't want anyone to be surprised. So we have right of entry forms where we say, okay, you know, homeowner, we are going to put a hole here, here, and here. And this is how we're going to restore it. And this is what we're going to do. Are you good? You know, before we touch anything, because we never want it to be a bad experience for a homeowner.
And along the lines of service and geography, an audience member asked a question about arrangements of water supply between the suburbs and the city. How are they negotiated and managed?
Oh yeah, that's a whole nother talk. Yeah, so we feed 47 direct connects, and that eventually feeds out to 120 suburbs. And those are we're actually have traditionally always had a flat rate for our cost of service. just because of the sheer number that we have, but we're actually transitioning right now to the AWWA cost of service model. So now we're undergoing a lot of negotiations and renewing contracts to try to make sure that people are paying for just what they use in terms of the suburbs. And so that's been an interesting experience, but at the same time, if you remember that map of Chicago that I showed and all the suburbs that we serve, it's pretty much a whole ring around Chicago, except for the southwest side. That's where we really traditionally haven't fed a lot. There's a lot of systems on groundwater, but unfortunately that groundwater is drying up. So we're in the process of working on a big contract for one of the suburbs on the southwest side, and they will most likely feed several other suburbs out there because they're running out of groundwater by 2030. So we have a whole big construction project for a 31-mile tunnel out to the southwest side and continuing to to grow our service area. But when we do that, we want to make sure we provide the best water quality we can. So I never want to provide something that's so far out that I can't maintain the phosphates levels. So our corrosion control for lead, because what I do here at our treatment plants impacts everyone. And if I can provide the best, most optimized corrosion control, then I can help with lead levels, not only in Chicago, but in all those suburbs. And so that's a really important key to that suburban growth.
Got you. We had a couple of questions on the department itself. One being for the facilities, the treatment facilities, do they have their own power supply sources?
Well, what we have is a lot of backup generation. We have multiple lines coming in, or ComEd is our electrical supplier. We have multiple dedicated lines to each of those facilities because we never want to be without power, of course, for drinking water, but if you think about it, it's for fire suppression too. I don't ever want to have a fire going on and somebody hooks up to a hydrant and there's no water there. So even if the water isn't potable, the key is always to be able to pump it. And so in addition to those individual dedicated ComEd lines, we have a lot of backup generation. Actually, we just finished a whole building at our Jardine plant dedicated to housing the backup generation that we kind of beefed up in recent years. But we also have a lot of like UPS systems, if you're familiar with those, and making sure that we have uninterruptible power supplies for each of those stations.
Got you.
Yeah.
And does the department have its own? Go ahead.
Oh, go ahead.
I was gonna move on to whether the department has its own research investments.
Yeah, actually, you're looking at her. So when I first started, I was replacing a previous director of research and development, and the fact that I had a PhD in engineering was, I think, part of the reason that they were looking at me, because I could both be sort of a day-to-day engineer, but also be able to provide that research expertise. And I love that. I absolutely love that. That's totally my jam. So when I came in, I was able to sort of grow our research program. We actually have a pilot plant here that's mimics the full scale flow of Jardine at a micro level. And we have an ozonation process in there, so we could do some experiments with ozonation. We did experiments with optimization. We have done just a ton of field work with lead. The fun thing about doing what I do, honestly, is that I get to do essentially academic level research. I have staff at my disposal, and we can make real time changes. So as, for example, with our lead test kits, we were taking samples, giving people bottles and instructions and having them sample the first liter 3 minutes in and then 5 minutes in, meaning like we try and get essentially the water in contact with the faucet, water in contact with the lead service line, and water that hopefully just came right from the water main. Just to, again, try and get a better sense of sampling. And that's actually how some of the genesis for the federal lead and copper rule changes to that 5th liter is based off of our research that we did with those sequentials. But we were realizing that actually the more data we got back in, maybe 3 minutes wasn't our peak lead level. We were actually able to change it to 2, change our instructions, and be able to see the data come in and validate that theory. And then once we realized people were making some common mistakes, we were able to change the instructions, but we did a statistically significant study as we changed the instructions to see the impact of more graphics, the impact of giving people a time frame, like you have to get this back to us in a certain amount of time, the impact of texting. But we did it to the extent where we could say something statistically significant about that data and say, oh yes, okay, this change is valid, it is worth doing, it is increasing the amount of kids we get back, and then the amount of kids that we get back that are filled out correctly. So we've really tried to put research and into everything we do so that we're making data-driven decisions as a modern utility.
That's really cool. It's interesting that the example you gave was all about human behavior and the
Yes.
human element as
Yes.
opposed to water itself.
Yeah, it's really, we get to do both because it is so much human behavior. And I always like to say that I'm a data geek, but I love seeing the impact of even marketing. People say, okay, well, just, put in a bill stuffer to initiate this program or send out emails. I'm like, oh, well, let's track that. Let's see, do that. Let's look at the impacts. Who's responding? What are their demographics? Are we hitting all the neighborhoods? Are we getting folks who don't use email if we email everyone? And so trying to look at the analytics of all that from a research perspective and a statistics perspective, so that we really are saying, yes, we're hitting all the neighborhoods, or, hey, you know what? No, we're not hitting our seniors maybe. And we need to do a different tactic. Or, oh, you know what? Sometimes if we're trying to hit a younger crowd, emails are the best with a link, specifically because humans naturally are lazy. If we have a link that we click on in an email, we're going to be much more likely than if we have to go type it in. And just those little things that are human behavior, but looking at it from an analytical perspective.
Got it. Well, we've hit our hour mark. I'd like to thank again Dr. Andrea Cheng, Commissioner of the Chicago Department of Water, the Water Center as well, for making this event happen.
Thank you so much for having me here today. This is great.
Awesome. Sorry we didn't get to everyone's questions, but we'll figure out a way to do that.
Yeah, and I can always take questions later. I'm happy to, if anyone wants to collate the questions or send me an email, I'm always happy to chat about water. It's really getting me to stop. That's a trick. So
Great. Happy Friday, everyone.
all right. Bye-bye.